General Protocol Spaces. Banking on Freedom.
Right. No further ado. Let's get started. So welcome to General Bull 23 of N. We're going to talk about two things that they're a little bit related, but not they're basically two different things. But VM, the virtual machine limits, which is a very important topic because it's related to the upgrade for not this year, but for next year, for the 2025 upgrade. There's a significant number of people who really want this for various reasons. And I thought it would be good for us to discuss, what GP thinks about that chip, what it is in the first place, and then what GP's opinion is on it. And we also have our own separate opinions as well. And then the second is on-chain oracles. So probably most people who have some relationship to crypto are aware of Chainlink, this thing called Chainlink. And it became, I don't know how used it is, but it became a highly ranked coin in market cap and so forth. But really what they do is quite simple. But so how can something like that be done with BCH in a way that makes sense? And General Protocols, our team has experience with that, right? Because we do run oracles because they're necessary for any hedge protocol. And we have thoughts about how we've done it so far, and then how what's possible, the other ways that you could do oracles. And especially we're going to talk about on-chain and a design that Jonathan has come up with. So let's get started. And if anybody wants to join up with us, wants to come on stage, please just raise hand or send me a DM or whatever, and I'll throw you up here if we know you. We'd be happy to talk. I see Jim in the audience, Turek, any of you guys. So you guys want to start with the VM limits. So I talked with Uname, and Uname says, it'll be like a 2-minute thing. And I think it'll be longer, but let's see. Right? because I think some of the things that are obvious to us, or our opinions, are not so obvious if you're not literally thinking about these kind of things every day. And I've seen also difference of opinion in kind of the finality of the chip. So the chip is the cash improvement protocol. Cash improvement process for deciding consensus changes on Bitcoin Cash. And I've seen differences of opinion. Where is it along the process? Is it totally done? Is it totally agreed on, or it's far from that, or where is it? So let's write down our answers on paper, like mentally, for a second, and then compare notes and see if we all agree on where it is. Uname, you want to describe what the VM limits chip is proposing in general at a high level?
Wait. I thought you were gonna ask me to give the 2-minute version or even the 5-second version. I have a 5-second version too. But anyway,
okay, yeah.
let's just lay out what the VM limit chip is. I mean, you can probably tell from the title, but it is essentially a proposal because right now, BCH, the BCH scripting ability, the general smart contracting ability, lays in is mostly, almost entirely, stuffed in unlocking scripts in inputs, and each input size is greatly limited compared to many other blockchains, uh, especially the EVM blockchains, where that can grow to a very huge size. Since we activated cash tokens, we now have ways to link this unlocking scripts together, multiple UTXOs that are propagating can form little machines. So that is mitigated a lot, but it's still a huge pain in the ass to develop around. So the proposal is to lift that limit in a controlled way, in order to fit more things into each input and make the lives of developers easier and enable more experimentation with the scripts.
Wow, that was very nice. I want to add a little bit higher level for people who might be listening to the recording that when we talk about the inputs and so forth, you can just think of it as code, right? Like when you spend money on Bitcoin Cash or Bitcoin any kind of chain like Bitcoin, you're running a very small program that checks some things, and then if all those things are okay, it says okay, you can spend this money. And smart contracts are really just an expansion of that logic. So you take that very simple logic that you do on normal spins and you do more logic than that. So you check, oh, how much is it? Who is it going to? Where is it coming from? How many are there? What was the time on the there's all kinds of what was the block time? Is it after a certain block time? There's all kinds of rules and logic you can throw in. So that's the whole idea of a smart contract. It's just code that you can run to decide whether you send money or not. And while these limits are very small and constrained, what you can do in that logic is very small and constrained. And there's some things you can do which are quite interesting, like AnyHedge, which we designed within much more strict limits than we have right now. But you really run into the walls pretty quickly when you're trying to do anything interesting. And so having those relaxed or expanded a little bit makes it so that you can put more interesting things and do more interesting things without having to do hacks like Yunei mentioned, where you split up your code and your activity into little tiny pieces.
And a lot of times that splitting, even if it's possible, it increases complexity. And as we have seen repeatedly in many other places, increasing complexity is a cost, and that cost is very significant. So allowing people to simplify their designs in a controlled way is valuable.
That's true. Yeah, the complexity is bad news for anything like smart contracts. That's actually going to be the topic of the presentation that I do at the BCH Bliss conference coming up in May, which happens at the same time as the Bitcoin Cash upgrade. So yeah, either come to the conference or we'll publish it later. But you should definitely think about coming to the conference and hear this kind of topic.
If you haven't.
Yeah. There's a Twitter account, right, at BCH Bliss with no spaces or anything, I think. And then there's a website, www.bchbliss.cash. I don't know, but you'll find it if you just look on Twitter.
www.bliss.cash.
Bliss.cash, that's what it is. So, yeah, it's a big deal. Now, but the interesting thing to me is always that it's relatively easy to say these are the benefits of something. These are all the good things we get from it. That's relatively straightforward to see because it's very direct. Like, I want this. I'm trying to write this program that does this logic so that people can have interesting and powerful smart contracts to help them do things, whether that's conference tickets with resell code or whatever it is in the things that you want to write, or like some kind of time lock vault or rules on inheritance vault or something like that. But it's very easy to say that. I need more space so that I can do this. But then it's very hard to say what's the cost of that, because the cost is much less direct. It's harder to see the cost of things. And this, in my opinion, is the key issue that hasn't quite been sorted out on this VM limits chip yet. Like, you really have to explore every little corner you can imagine to make sure that you're not leaving a hole in the ship. Because once you finish these designs that go into consensus, these aren't like normal software. With normal software, you just upgrade it and you're like, oh, we had a bug and we fixed it. But with consensus code on a permissionless network, you have all these nodes running it, miners running it. There's money locked into contracts that are following a certain set of logic. You have a hole in the ship and you may have to wait a year or to repair it, or you may not ever be able to repair because people have put, billions of dollars into contracts that have this flaw and so forth. So you have to be very, very careful with these. It's not like normal software engineering. This is more like mission critical type software engineering that you have to do for these. And that's
can I jump in?
Kind of my opinion there is that we have to explore that more. Yeah.
Yeah, so I have a slightly different opinion on that state. I think it's fairly well explored, but it's definitely not fully explored yet. So the way I can kind of showcase this is that over a year ago, there was some examples in the ship that explained some worst case situations, like if you want to abuse this limit, do this kind of action. And for many months, we like looked at and talked about those cases, and they seem to be the absolute worst ones. But since then, there have actually sprung up another example that's even worse than previously known, and the ship has since been updated to reflect that change instead. So even though it is fairly well explored and a lot of people have looked at it, there might still be more edge cases and more specialized things to consider before we can say that the ship is fully ready.
Yeah, and I just want to comment on something that's a little higher level than this, which is that, of course, we can talk about how much exploration is enough, and to which extent should we let something simmer, and since we established the process, we have seen some great examples of debates and explorations leading to more complete specs and mending up the corner cases and holes, and that is all great. But now that we are in 2024, and even before the adjustable block size is activated this May, and we are already looking forward to something for the next year, we it's kind of dangerous to take things for granted, and I think it's been showing up here and there among the community a lot, and it might be inevitable, because even in very, very, very well established processes in the real world, eventually, people not even necessarily, get lazy, but rather when the process becomes seen as reliable, people start taking it for granted and stop investing in the process itself, or even start dissing the people who want to invest in the process itself. Wow, why are you wasting my time? Why do you create all this uncertainty? Why do you want to explore? This is a no-brainer. Stop getting in the way. What if this doesn't get activated? That would like screw you guys for throwing sand on my path to greatness. That kind of things can come up all the time everywhere, and I kind of want to caution against that. Like, you know, an orderly process is only as valuable as how much people invest in it. So yeah.
I can put an example to that. So Bitcoin Cash Authis, who I often praise, did an amazing job of putting his ego aside. I'm sure he has an ego. He's a very smart guy. He has lots of strong opinions and so forth. But for the purposes of pushing the chips that he worked on ahead, he totally put his ego aside, at least publicly and, in interactions. He took so much different feedback. He took things that he completely didn't agree with or whatever, and he tried to engage with all the feedback and work it out and keep improving until he, as the owner, as the effective owner, reached a point where he thought, okay, this is good enough. And there were still people telling him at that point, hey, maybe you have to think about this. Maybe you have to think about this. But he reached a point where he said, look, this is my chip, and this is the state it's in, and I think it's complete. And that's his choice. And that's one of the beautiful things about the chip process. You have an owner. The owner has the chip. It's not it's not some kind of community property. It's just a thing that you're proposing as the owner of the chip, maybe with collaborators. And he reached that point and said, okay, look, I know everybody has opinions. Some people think it's done. Some people think it's not, but it's done. And here it is. And that was agreed on. People agreed on it. And all of the ecosystem basically said, yeah, okay, that's fine. Yeah, let's do it. And that's the one of the great beauties of the chip process. It's not there's no vote. There's no there's no enforcing body who's authorizing or authenticating anything. It's just the ecosystem decides whether it does what they're going with. And I think we have pretty good precedent, like Uname said, where the chips that we've done so far have been investigated to a very serious degree, and they've simmered for a long time. And as Jonathan pointed out, things have been improved. Even when you thought it was done, you find out later, oh, there's more to be done, which is great, especially for something like VM limits, where if you screw it up, you invite disaster. You look at inscriptions on BTC, there's literally just bad coding, bad software engineering that happened. And according to the Callan, a very talented software engineer who works on Bitcoin Cash, Node, and other software like Fulcrum, he looked at it and he said he can't imagine how they allowed that. It was so, in hindsight, it was so obvious, like this limit that they missed that allows these huge inscriptions to happen where people are throwing, images and all kinds of stuff onto the BTC blockchain. So that kind of thing, we just have to make sure that we're looking in every corner we can think of. And I hope the owners of any chips, including the VM limits, will try as best as they can to put their ego aside, take feedback, listen to it. It doesn't mean you have to agree with everything, but at least hear it and look for improvements. And then at some point, of course, you reach the point where you say, you know what, this is done, and that's okay. So I'm looking forward to getting there.
Yeah, and overall, the most important thing is that you gotta invest in the process. You gotta participate. If you don't participate, the outcome might not be what you like.
Could you actually, Jonathan, or Uname, could you start since you mentioned it? Could you explain what that means to invest in the process? Because I think a lot of people don't get it, and we've seen it many times where someone writes a chip or something that they think is a chip, and then they're like, hey, I've done this thing. I described the technical specification. Everybody should do this. And then they stop. That's the end. They don't do any more, right? What does it mean to invest in the process? Like, what do you mean there?
So you gotta go from the beginning to the end, right? You first start off having an idea. Perhaps you pass around the idea to see if people are interested in the idea. Okay, people are interested, and then you write a technical specification about how that idea should go. A lot of people stop at this point, and then they expect that because people like that idea, it would just magically go all the way. That is not the case. But after they lay out the technical specifications, you circulate it. You circulate it. You get people's feedback. You continue getting people's feedbacks. You invest in having people build a test implementation, for example, and see how it would work. It would work out once implemented. You weigh the risk. You weigh the pros and cons. You weigh the pros and cons, and then you solicit feedback on those pros and cons. You try to go as exhaustive as possible instead of just yeah, I will write it up in five minutes. Uname can write it up in 5 minutes for me, and just lay it there. You go extensive. You go there extensively. You probably don't have to do it as extensively as cash tokens, but that is a good reference point. And then you get the test specification, you get the test implementation, and you test the hell out of it. And you continue and you build a checklist, and you try to solicit support. That is a grueling job. You try to enlist people, and so on and so forth. For the whole thing, I wouldn't go through the whole thing. For the whole thing, you just refer to past chips. Many of the things are there. They're all recorded. The cash tokens chip, the adjustable block size chip, they kind of have the whole trail, paper trail laid out in there and recorded. You can refer to them. Yeah. So this I mean, this is not something limited to a blockchain decision process chip, the chip process. This is something that is also true and often observed for real life processes. I mean, I don't like to use this as an example, but this same problem plagues a lot of very long established processes like elections. People bitch. Uh, yep, in a very extreme example, people go bitch on Reddit about something they don't like, and then the election comes. They don't participate in any of it, and then after the election, they continue to bitch about it. Oh yeah, I bitch on Reddit. Why is this thing not happening? That is an extreme example, but you get the point. No.
Right. Jonathan, did you have you agree with that, or you want to present a different way? What does it mean to follow the process, to take something from beginning to end?
Well, I'm not going to talk about follow the process in the beginning. I'm going to talk about specific invest in the process perspective. So you can either be the owner of a chip, that's one, maybe a few people if they collaborate, or you cannot be, which is the vast majority of us. And so investing in the process is not something that only the ship owner does, right? Every participant who is a stakeholder and gets impacted by a chip should be taking some time to at least read through and maybe ask a few follow-up questions to the chip owner. They could make their voice heard early on, and if there's something that's testable, they could try it for themselves. Now, I understand that out of hundreds, if not thousands of stakeholders, you're not going to get every single party coming back with good feedback. But not having looked at it at all is, in my opinion, that's below the bar. So when chips come up, at some point during their path from the beginning to the end, the owner will have created a list of stakeholders, people who are impacted by the changes in the chip. And they should reach out to those. But if you look at that one and you see that, hey, you have listed A, B, and C here, but you haven't listed D, and D should also be a stakeholder, then you should go back to the chip maker and just tell them hey, I think you missed this party, because it is a collaborative effort, and someone who's good at one thing isn't necessarily good at a bunch of other things. So making a chip is a relatively complicated thing, and the chip makers, at least everyone I've spoken to, are all very happy to get feedback and very happy to know where there are shortcomings, because most of the time, if you have a great technical idea for an improvement, then that's probably because you're good at technicals. That doesn't mean you're the best at knowing what companies are out there, who is using BCH. You might be able to say that, hey, my change here impacts miners, right? As an example, the group miners. But you don't know who all the miners are, you don't know their contact methods and whatnot, and you don't know how to reach out and get their feedback. So other people who maybe aren't as technical, but have ties, have connections, have contact mechanics, should really help, if they can, put all these things together, because the best outcome for everyone is when everyone is actually engaged in the process. And so to me, that is what it means to invest in the process.
Yeah, and people are generally a lot less happy if the feedback or contribution comes in June the next year. So yeah, also be timely.
Right. And we can put this in contrast a bit to the history that we came from, which is the bit process on BTC, and what used to be just generally Bitcoin. It's in hindsight, when you look at it, at the time you're like, well, the people who know what they're doing are doing the thing, and it's all right. But in hindsight, you look back and what still exists on BTC, and it's very kind of disturbing. It's like, wow, that's an extremely centralized process. Like I just saw the other day, some guy, he's very smart, intelligent person, trying to develop some more or less smart contract systems that he thinks will help scaling on BTC. And he just totally, it's just he doesn't even think about it. And he's just like, well, I applied for a BIP number. And you're like, what do you mean you applied for a BIP number? Are you not allowed to have a proposal if you don't get approval from the kingmaker? Oh man, I'm just so glad we got out of that. And we're in this process where, yeah, it's a huge pain in the ass. It's a ton of work, like you guys said. But it's just up to you how much work you put into it as an owner of something that you think is important. So I'm very glad at where we are with the chip process in Bitcoin Cash. So the VM limits, back to the VM limits. Could you, Jonathan, or you name, which one of you is more familiar with the specific limits? So I don't think we should explain in detail, but just like a bullet list of what it means in a little bit more detail to expand the VM limits.
So I don't have the individual items in my head. So if Uname does, then he's better at that. But I have gone through the VM limit chip a couple times. And I think for most of the part, I like most of the changes. There's one exception that I can mention off the top of my head, though. It's the change of the max length to something like 10,000. And I actually challenged Jason and said that I mean, all the arguments for 10,000 that's listed in the ship are perfectly reasonable and follows logic. But I keep having this nagging thing like what if there's something we don't know? Should we really make a jump this big at the first get-go? Even though we can motivate it? Because we can never actually know the unknowable. We can never know what we don't know. It's like a big thing there. Even if we look at it for years, we might still be something that's missing. So to me, a conservative move a little at a time is something that I'd prefer to do. Although that did not answer your question. So Uname, do you know what all the items are?
Well, just a quick point about that 10,000. This is relevant, and I totally agree with you, because the expansion from what we have, which is what, 500 to 10,000, is that what it is?
Yeah, something like that.
It's like more than an order of magnitude increase. It's a very large increase, and with any very large change, there's room to fuck up, and that is one of the things that you would have to investigate extremely carefully, and or be more conservative with the increase, and then increase it later again if you want to. Something like that.
Yeah. So I just want to point out, by the way, just for clarity, that I'm not against the VM limits in any way. Actually, I look very much forward to it, and I think Jason has done an excellent job at pushing the boundaries of that forward. And one of the main reasons why I'm very supportive of the VM limits, although I can find things in it that I don't like, overall I really do like it. So one of the big reasons why I actually do like it a lot is that it answers a question that we weren't asking before, that people kind of forgotten about and not really taking into consideration like on a day-to-day basis anymore. And that is, what is the cost of not doing it, right? What is the cost of the current VM limits, the choices we have already made, and are those sensible? And so the VM limit chip actually goes into detail and explains kind of like why was many of the current things chosen and why were those bad choices. And even if it doesn't point out like the absolute perfect know-it oracle from the future what the choices should be, it showcased that we have a lot of things that are misaligned in the limits we have today. For example, like count the number of opcodes in a script and use that as some kind of like single metric to limit bad stuff. Well, There are opcodes that doesn't cost much to execute, like an if statement. It's not super expensive, maybe it is, or just a push a single byte into the stack, not that expensive. And then there are things that are really expensive to execute, like do a signature verification, which is many orders of magnitude larger than simple pushing on a stack or reading from the stack.
Or do a SHA-256 hash.
Yeah, exactly. And so we are currently in a state where our metrics for determining what the cost of something and the limits from a safety perspective are already misaligned. They are not a good target based on reality. And so I think the VM limit chip is a really good step towards fixing that misalignment.
Yeah, and it's a step towards a much harder question in the future of how do you charge for transactions? That's a much harder question, but it kind of goes in that direction of, hey, we probably have to answer that eventually, and wow, that'll be an interesting one.
Yeah. I just want to add to that. So in smart contract oriented blockchains that are built from scratch, like say Ethereum or EVM blockchains in general, these limits and even transaction fees are based on gas, where each operation, for each operation, you comprehensively measure each operation and decide how much processing power they consume each, and then assign a gas value to them, and you charge for them according to that gas. That is a model that assumes that the primary cost is processing. In Bitcoin, though, Bitcoin and Bitcoin Cash, we historically have not used that model. We have used another model that assumes that bandwidth and storage and memory are the expensive things, and we should try to charge based on that. And processing is relatively cheap. That's the assumption, which holds true to some degree in our UTXO context. And we just need some safety limits to make sure that we don't bust processing wherever we go, and that's about it. That historically has worked okay, but as Jonathan said, that there are some cases where this gets really weird, like the operations of hashing or signature, that where for the same unit unit storage that it consumes hundreds more times of processing than other comparable operations. And so historically that has been basically kept under a lid of a hodgepodge of weird safety limits that are stacked on each other. So touching any of them is kind of a dicey prospect. And the nice thing about this VM limits is that I don't know if this counts as nice, but it doesn't change this model. We are still keeping the Bitcoin model of charging primarily on bandwidth and storage and memory, how much space a thing consumes. But the lids that we keep on those expensive things are changed to a significantly more reasonable degree. We are actually limiting the things that we should be limiting, such as hashing, instead of blanket limiting things where it's very constricting and otherwise also concerning, depending on which operations you're looking at, such as limiting opcodes.
Yeah, to put that in a little bit higher level, an example that would be, you have a program that does a bunch of simple things, and it's a large program, but it's very simple and it's very cheap for the miners to execute and validate. But then you have another program that's the same size, looks the same on paper, but it's doing hundreds of signature checks or hashing executions, something like that. and the difference in cost between these is enormous from a processing perspective. So, and especially once you get into something like denial of service vectors, where people can try to cause problems for miners in the network and so forth. So yeah, just to put a comparison, same size program with different contents can be completely different in terms of its impact on miners and validators.
Yeah, imagine you operate an airplane and you take in passengers, and you charge tickets. You charge the same amount per ticket, and each ticket is for one head. That sounds totally reasonable until you realize that your plane takes in both humans and elephants.
It's a big plane. It's a big tent. It's a big tent plane. All right. So the VM limits are there. Matthew's here. I invited him on stage. I'm sure he could list up the limits. But yeah, we won't go through this. But anyway, I think everybody listening probably gets the idea. We're talking about the limits that you put on the code that you can run whenever you're spending money. And yeah, as Jonathan said, we felt that very strongly because we started developing smart contracts for BCH back in 2018, and it was extremely painful back then. The VM limits were much more strict. The size of everything that we could do was strict. The amount of opcodes available was less. The things that you could do was less. Yeah, so we know the pain. We totally understand the pain, and we want it to be bigger and easier, and but at the same time safer. Yeah. Or safe.
To be fair, I don't think the actual limits have changed that much since then, but we have gotten a ton of great optimizations. That means we don't need to waste like 80 to 90% of the space anymore.
Yes,
compared to what we
had
right. to do back then.
Yeah, we have some articles we published back in the day that show with the availability of new opcodes how we were able to cut out huge chunks of code where we were having to do things in a kind of manual, ugly process. That now it's all built into the virtual machine. All right, so let's. Oh yeah, go ahead.
So now that we're like 2 minutes in, is it time to talk about the oracles?
Yes, we're gonna go on to oracles now. Let's do it. Can I do my newbie introduction to the way it works, or did you want to start with something else?
No, go ahead.
All right. So as I introduced a little bit before, let me just recap a little bit. There's the idea of oracles, and for somebody who doesn't know about what that is, it's just where if you have a smart contract or something on Bitcoin Cash or Ethereum or whatever, and it has a decision to say like, oh, I'm going to pay out this much to somebody, but it depends on the price of Bitcoin Cash versus gold, or the price of Bitcoin Cash versus US dollars, because I want to pay out in US dollars terms. That information doesn't exist on the blockchain, right? That doesn't have some absolute reference that you can just point at and use. And you can't have a smart contract that's like, oh, I'm going to go hit up the CoinMarketCap API. It doesn't work like that. So you have to have some way to get data into the smart contract and make a decision and say, okay, the price was $450 per BCH when this contract executed, and blah, blah, blah. And it does its own logic with that to decide how much to pay out. So that's what oracles are. And that's one example. Price is one example, but oracles are just the idea of providing information and making it available into these contracts. So the way that the current oracles that are in use on Bitcoin Cash are the ones that Jonathan and General Protocols designed, and they basically work as General Protocols. The oracle publishes a string of messages, and they're actually a chain of messages because they have a connection from one to the next. So there's a chain of messages, and each message has a price and a time. Like this price was published at this time, and it's signed. So the oracle signs it, and that signature is very important because when your contract uses a price, it can't just use from anybody, because you couldn't trust that, because anybody could publish any price. But your smart contract says, hey, I know this guy, I know this oracle, and I have here a price from them and a signature from them. So I know that this price is okay. I trust this price and we use it and go on. That's how the current setup works. The Oracle publishes a string of messages. Did I get anything wrong there, Jonathan, before I move on?
Sounds about right to me.
All right. So this has some problems. It has several problems. I won't go into all of them, but one of them, for example, just one example of a problem with this is we publish a chain of them. So there's a chain of these messages, but the Oracle could publish, split the chain and publish 2 chains of these messages. And this doesn't mean on chain, right? These are just messages out in the ether, like just data that's available, and you can request it or you could store it or whatever. It could publish 2 chains of prices, and you wouldn't really have a way to know that happened. Another problem is just the common goods, the commons, the problem where there's an expense associated with publishing all this and running the infrastructure and doing the data, and the risk of everybody hating your guts when something goes wrong or there's like a bug or something like that. There's no compensation for that, right? So these are 2 examples of issues that this thing Jonathan came up with tries to resolve. And there's more issues, but these are 2 of them. So the way this other proposal works is, and I'm going to get this completely wrong, and Jonathan's going to correct me, but I'm going to try to explain this at a level that works for me and I hope for the audience, and then Jonathan maybe will correct it. But it's fundamentally, I think, correct. So the Oracle now, instead of doing this thing where they're publishing data off into the internet somewhere, they're actually doing this on chain. And they publish a new token, so an NFT, that says this is the state of the Oracle. And so there's one token sitting there on chain. And this token has a price and a timestamp, just like the other one did, right? But there's no signature here because the token itself is the proof of this is valid data. Because this token is validated by miners. It's a miner validated token. We issued it. The Oracle issued it. If you trust this Oracle, then you trust that token and what it says. And it has a price and a timestamp on it. But now everybody can't just use this one token because that'll be a mess. So what this token does is it creates, you can create a set of validation tokens. So it can spawn off let's say 10 tokens. And those are sitting out there. And whenever you have a contract like AnyHedge or something else that wants to use that price, all it does is it takes that validation token as an input and it says, okay, I have the token here. And now my contract can read that token and check, okay, the price and the timestamp, that's the price and the time. Okay, we can use that. And it can implicitly know that this is valid because it came from that token. There's no way that token was created by anybody but the Oracle. So you implicitly trust that it's there. You don't need to do a signature check anymore. All you got to do is use that token. And the contract forces, because with UTXOs, you can't just touch something and not consume it. You take that token and it's consumed. It's destroyed. But you magically create an exact copy of it and put it back where you got it. So your contract comes in, picks up one of these 10 at random, uses the price, creates a new one, and puts it back on the pile for other people to use. So that's the main step. And then when the price updates, like every minute or 30 seconds or whatever it is that your Oracle follows, all it has to do is update that main token to the state token to say, okay, this is the new state. The new state is this price and this timestamp. And at the same time, it will take maybe 5 of those outstanding 10 tokens. And it'll say, okay, these are the 5 current ones and these are the 5 old ones. And it just takes the old ones and updates those to the new one. So you have just this constantly rotating set of the newest price and the previous price. And then people are mostly just using the newest price. And then the Oracle is free to take the old ones and refresh them, or really destroy them and create a new set of 5 that others can use. And when you use one of these, the validation tokens in your contract, it has an additional requirement where it says, okay, you can use this price, no problem. One of the outputs of this transaction has to go to the Oracle, which is defined in a certain way. So you have to pay a very small amount to the Oracle in order to use this. And so this solves that tragedy of the commons problem. And not only that, but it lets other people look publicly at the Oracle's funding and say, this Oracle has no money. I'm not sure I can trust it. Is it really going to be operating a year from now? Because I need this contract to be redeemed a year from now, and I'm going to need a price a year from now. But if you look at it and it's been running for a long time and it's well funded, it's like, okay, yeah, this is going to be okay. This also mitigates an additional third issue. There's many of them, but this mitigates a third issue, which is the incentives of an Oracle. Because when you're publishing prices, there's an ugly incentive that the Oracle publisher has an ugly incentive to get involved with contracts and then do some funny business with contracts. Like publish a wrong price that's way too high or way too low, and which is a famous thing that centralized exchanges more or less do. It's just they don't use oracles. It's just built on their local systems. So yeah, Jonathan, what's my percent score on the description?
Over 50, but not much
over 50. Jesus.
Yeah. Okay, so some things we need to clarify. In the on-chain version, you said that the state is a price and a timestamp. And you could look at it from that perspective in order to, keep a simple mental model of the thing. But actually, the transition from our existing oracles to these on-chain oracles actually has a fundamental shift in that the original oracles we use today, they distribute data. And the signature is proof of that data. But in the on-chain model, what you get from the oracle is actually just validation. You only get the verification that it is correct part. You don't get the actual data. And there's a reason why we have this distinction. So let me go through one of the problems John did not mention about the current oracles. So we have a somewhat large number, like 20 or something oracles running right now. And these oracles have zero income, right? No one pays them anything. And the data they produce, they sign, so they expend computing resources, and then they distribute, and therefore expending even more computing resources and bandwidth and storage and memory and a bunch of things. Now, currently, for us, this works fine because we know that our oracles are going to be running for as long as we need them, because we make money on a second degree after that. Like we make money on the AnyHedge contract automation. And so some of the money we make elsewhere, we can kind of consider to be paying for those oracles. But if we were to continue along that path and scale that up and maybe get to thousands of oracles and hosting volumes for not just our apps and a small handful of others, but actually for like multiple decentralized exchanges or whatnot, then suddenly we're in a situation where the amount and the volumes using this data is so much higher than the value that the producer gets out of them, that we enter that, as John said, ugly incentive state. Now, there is no way with our current oracles to pay the oracle provider. Of course, anyone could just ask us, hey, it says that the GP is running these oracles. Do you mind if we pay you some money so that you can continue to run this oracle? Of course, you can reach out to us and feel free to give us money. We'll be happy to take some money. But there is no mechanic to enforce this in the current version 1 oracles we have. So if we were to want payment, like if we wanted to, for example, break out the oracles into a separate business entity and keep that far, far away from everything else we're doing so that it doesn't know about all the other things and therefore has a better security situation because it don't know what it would get involved in, it's harder for it to abuse its own power, then it would be in a situation where it's flying blind and it's flying poor because essentially no one is paying it money and it's expending resources. The best case outcome in that world is that the Oracle operator says, oh, this wasn't a good business idea, let's just shut down. And then suddenly everyone who depends on them sits there and don't have any Oracle messages anymore. That's the best outcome. The worst outcome involves those ugly incentives and abuse and a bunch of other things. Let's not go there.
And the best outcome is not good either. It's bad.
Exactly.
Yeah.
So looking at these on-chain proposal that I have here, the main big fundamental change is that it does not distribute data that you can use in contracts. What it does is that it offers you a validation service. You can take data and ask it, is this data valid? And it will say, if you pay me the fee, I will execute my code and you will know. And it's slightly better than that because it's not EVM based, and so it cannot fail. So if you give it the wrong data, then the transaction fails and you have paid nothing. So there's a fundamental shift here, that what you consume in the old version was data with a signature. In the new version, you consume validation. So you're paying for validation. So let
me try to frame that a little bit at a higher level. So as I said incorrectly, correctly, the old one provides the data, the price and the timestamp. And the new one does not provide the price and the timestamp directly. You provide the price and the timestamp based on the history of prices that the Oracle has made. You provide the price and the timestamp and you say, this is the one I'm using. And the token says, and I'm sure Jonathan's going to explain this a little bit, but it uses a Merkle tree so that when you execute using this token, you can provide like a small amount of data, and then the token will be able to verify, like, yeah, I published that. I did indeed publish that, or the Oracle did indeed publish that price with that data. Yes, that's correct. And so then you're able to use that price. Is that right?
Yeah, that is correct. So it's a bit technical, but so if we go back and we start this from the very start here and talk about the technical side of things. So first we have to create a lock script that is going to act as the central identity for the Oracle. In this lock script, we will have a function to initialize the oracles. And one of the many paths inside of this lock script is the initialization part. So on day one, we don't have an oracle, and then we run a transaction on chain that locks and unlocks things from this lock script with the initialization. So what happens when you do this? Well, the contract issues some tokens. It issues a collection token, which the operator can use to collect fees from the contract. It issues an attestation token that the operator can use to update the current state of the data that the Oracle wants to provide to others. And then it issues an internal state token, which contains everything the Oracle needs in order to validate something about the Oracle's past. And this something is the data, all possible data back in there. So this consists of a Merkle root hash and some other metadata. But the important part is that with this data, the Oracle can validate any point in its past history. And then it also issues a fixed set of validation tokens that it moves out into a separate lock script, the validation contract. So that's the initialization. So after you've initialized, you can
Let me add something just to emphasize the thing where Jonathan said it can prove any data that it has published in the past is correct, but equally or even more importantly, it proves one chain, right? You can't provide data from some other whatever. It's one chain of prices. So this solves that problem that I described before, where you really have to kind of trust the Oracle even more than you want to in the first place, not to be producing multiple versions of the same price. So because once it goes into this validation structure, the Merkle tree, and you provide the Merkle root, you can't produce a previous price that falls outside of that single chain of prices.
Yes, that is correct. So after you've initialized the Oracle, the operator now has two tokens. One of them, the collection token, that is there so they can collect the fees. Ideally, it puts into long-term storage somewhere and keeps it safe. And it's not supposed to be used very often because unless the Oracle needs to get the money off of there often. But the idea is that there should be money on the Oracle so people can see that it has proper incentives. The attestation token is different from the collection token in that it is essentially the key used to update information on the Oracle. And the reason why we have it separate as a token is that you can then have, like, some machine on the internet can create prices, but they can't take the money. And so you can have separation of responsibilities, which is always a good thing when you're designing systems like these. And then the validation tokens that it's sent out to the validation log script is, as John explained before, how consuming contracts interact with the Oracle to get their data validated. Now, from this point, the Oracle enters a loop where every now and then it creates a new transaction. And in that transaction, it provides the attestation token, and then it sends the attestation token back to itself. The presence of this attestation token in the transaction means that they are authorized and allowed to update the Oracle state. And then it takes the Oracle state token from the Oracle contract, breaks down as much as needed in order to get the parts of the Merkle tree it has, adds an additional leaf to that Merkle tree, and then binds it all up together into a Merkle root, and puts that Merkle root and updated data into the commitment of the state token. And so every time the transaction like this happens, the state token changes its internal data to include a new and updated Merkle root. And it also pulls in, as John said earlier, a subset of the validation tokens, some of the older ones, and updates them with the latest data. This is the general process of the Oracle. Initialize once, and then keep making transactions that simply update the data by doing attestations to new data. And I use the word attestation here to make things as clear as I possibly can. A lot of people hear the word Oracle, and they think it's some magic thing that knows stuff. I use the word attestation instead because it has already existing ties to how the world works otherwise, and it's actually the only thing an Oracle does. It observes some data in real life, and it attests to what data it observed in a cryptographically provable manner. So when your contract wants to access and use an Oracle, it's going to need to provide the point in the Merkle tree, a given point of data, and the rest of a Merkle proof, all the other leaves in that tree, in order for the validation contract to be able to calculate the checksums all the way down to the Merkle root, and then validate the Merkle root against the stored Merkle root inside of the UTXO, the validation UTXO, the validation token. And so this is obviously not a trivial thing, like at the top of you look at it, oh, that sounds complex. But just like today, we have an Oracle relay, which you can ask questions about oracles, like which oracles exist and what prices have they issued, and can you give me all prices between this and that timestamp? There will be an indexing service that will keep an up-to-date state of the oracle's data. So you can simply ask that one, like, what's the current price, for example? And you will get the price, and you'll get the full Merkle proof in the correct format back. And so as a developer, you actually don't need to know that much. Just ask the service, get a price, call in this validation token, provide the data you got from the indexing service. And if your transaction doesn't fail, then you can know with absolute certainty that this price was a price point that existed in the oracle's past and that it was valid. When you do this, the lock script of the validation contract is also going to tell you have to pay the oracle a fee. And in this context, compared to the version 1 oracles, there is now an enforced mechanism for payment. But in both of these versions, you have access to the data. You can all just ask the indexing server, what's the price? And it will give you an answer. You could even go as far as to try to replicate, like take the Merkle root out of the validation contract by doing your own indexing service and copy over that, and then do all the validation inside of your contract so you can avoid paying the oracle a fee. That is technically possible. But no matter how you do that, unless you also implement in your contract full chain validation of the Bitcoin Cash blockchain, you can never mathematically prove that the oracle issued it. So whomever uses it in a way different from the way described here with the validation contract, they access the data, but they don't access the trust. And so their trust model becomes the same as any other, trust me, I do the right thing here. And no user who uses contract that follows a different trust model from that perspective can say that, yes, we are using this oracle. Because what they're really using is, yes, we're using this middleman who happened to try to replicate this oracle, but is also a man in the middle point that can really mess with your stuff. And so now that we have a change from you pay for data to you pay for trust, we're in a good state when it comes to the oracle incentives. And because you can only use this one step out from the oracle, you also can't fake how much value you are using it with. Let me explain that in a little bit more detail. So imagine you have an NHedge transaction and you want to use an oracle in it. The oracle can now say, you can use my data, but using my data will cost you 0.1% of your volume. Where before we had no way to enforce anything. And if you make an oracle and you get a handful of contracts to actually pay you as intended, then those fees might very well sustain you for like a year going forward for issuing more oracle messages, which is a very good model from that perspective. However, you really need to get up in volume further if you want to be able to confidently say that, yes, this oracle has more to gain from being honest than being dishonest. The good part is that in the old model, you can't know. You can't know how much of the NHedge volume, for example, we consider to be oracle income. And so you don't know how much our oracle side of the business is considered to be earning, and therefore what its incentives are. But with an on-chain Merkleized attestation oracle, like the ones we are talking about right now, you actually have on-chain a full history of all the oracle payments.
Yeah.
And that changes things quite dramatically incentive-wise, because now people can look at it and they can say, not only, yeah, this has been around for this long time, but they can also say that, yes, they are a healthy oracle that are earning respectable fees and that they have a strong incentive to continue to be honest going forward.
That was beautiful.
Right. Yeah, I think that explains like the basic construction for this on-chain oracle. So there's some more things like how do we handle metadata and How do you deal with the Oracle fee collection? What's the life cycle of all these things, and what are the limits on this system? But generally speaking, we have now described the core of the system.
Yeah, it's great. And I want to reemphasize one of those points that Jonathan made, which is this doesn't do anything to try to hide data. Right? There's no data hiding going on here. All the data is out in the open from the very beginning. What it does is, if you want to if you want to access the trust relationship with this Oracle and say, hey, I expect you to be available as you have committed. That's part of the Oracle's commitments. There's a metadata to them where they say, I'm going to be available until this date with these properties, and you can trust that prices are going to be available, or whatever data the Oracle is providing will be available until this date. If you want that kind of guarantee, then you can participate in the system. If you don't, you can just use the price, whatever it is. Whoever's publishing one of these, you can just use the price. But then it's on you, right? The trust is on you. So, for example, if you're doing just smart contracts with yourself, who cares? You just use price yourself and put it in there. It's like a one-person thing. It might actually be easier to use one of these because there'll be infrastructure around it. But if you just want to use your own price, who cares? But a lot of things that are interesting happen between multiple parties, right? 2 or more people are involved in contracts. Then they become interesting. And in that case, it becomes valuable to be able to say, hey, trust me, bro, trust my prices. And the other party is like, I like you. I want to trust you, but I don't trust you. You know what I mean? When there's more than one person involved, then it becomes valuable to have this third party that's providing a service that both of them can trust. So yeah, there's no data hiding going on. I wanted to re-mention that.
Yeah, so in the description we've given so far, almost all of the parts we talked about are on the infrastructure side and not really on the feature side. Like, what does this actually give you? I mean, yeah, it gives you more reliable, more auditable, and more open oracles, but what can you do with them, right? That's a question that has also changed. So with the current oracles we have, you have this data and a signature. And with that, you can do quite a lot of things. But for simplicity, the way we have it right now, at least for AnyHedge, is that we have some data that we acquire, some data we observe, and then we're doing some aggregation on that data, and then we are publishing that information with signed packages that the contracts consume. So if you are a user looking to enter into a smart contract that uses this, then what are your actual guarantees here? Well, you are guaranteed that your contract will execute using a price that comes from a signed message. And the Oracle swears solemnly and promises that it's behaving in a specific way and that it's getting data from a certain number of sources and that it aggregates them in a specific way. But you don't verify that. That is something that you trust because you trust the Oracle. That's internal or deferred several steps out. You could have multiple separate oracles that you take data from, and inside of your contract, do your aggregation. And that's fine, but then your contract needs to execute more and more signature validations, which, according to Target Deviant limits, is a fairly expensive thing. And that would give you, as a user, some confidence before entering the contract that, okay, the aggregation is going to happen in a very specific manner. But you'll still have to say that each of these oracles, you have to trust that they don't behave in a different way than previously described. So with these Merkleized, the oracles, the on-chain version we have here, you can actually do both of these models still. You can have an oracle that does pre-aggregation and you can trust that it does it right. And that's fine. But you can also have multiple oracles that don't do any aggregation and then you can aggregate them inside of contract. And that way you can get a confidence before entering into contract that the aggregation is going to happen in a specific way. When it comes to the failover, the reliability aspect and the trust aspects of an oracle, there are some questions that are difficult to answer in most of these systems. For example, how will the oracle behave if one of the sources it aggregates makes a post on Twitter stating they have been compromised? Well, you can look to the oracle today and you can read their policies. That's a good start. But it would be better, at least in my opinion, if the contract actually had, I'm using these oracles, I'm aggregating in this way, and if someone provides a metadata message from the oracle that states that it's compromised, then I exclude it and allow it to be aggregated with fewer entities, so that you know what the fallback and the backup behavior is before you enter into the contract. Now, I feel like I'm rambling a bit, but yeah, I really like the fact that we can do this and that it'll be relatively cheap to do this using the oracles, the on-chain oracles.
Yeah, and a bunch of other benefits come with it as well, as we've been discussing. So we probably need to wrap up soon. We've done quite a lot of technical stuff. I just wanted to mention one thing. The connection here, or one of the connections with the VM limits in this oracle, is this is yet again one of those places where General Protocols is in a position to say, hey, there's this thing we'd like to do. And there's more people in this position today than there were in the past. So this is not only us, but there's this thing we'd really like to do. But wow, it really pushes the boundaries of what's possible right now in the virtual machine. And not because those are like fundamental boundaries, just because it has these artificial boundaries on it for safety reasons. But some of those safety reasons can probably be expanded because they're not really involved with safety. And so having a more powerful VM and more space in the VM to do things makes this kind of thing easier and safer to do.
Yeah, and as mentioned before, a lot of the limits, it's technically not something that's impossible, but in order to cross it, you need to construct very sophisticated things with cash tokens, and sometimes the complexity is just not worth it. You have to greatly increase the complexity, and it gets too much to handle.
Yeah. All right. Well, let's wrap up. And Jonathan, thank you for carrying us from my 50% to 90% or somewhere on the correctness of the oracles. But this is really interesting.
Yeah.
I'm really glad you came up with this design.
So it's really worth mentioning that this is not a final and implemented and tested design. This is work in progress, and I think it has a lot of benefits. And compared to other actors in this space, it takes us a lot closer to what people expect to be there.
Right.
Like the Ethereum usage of Chainlink is pretty well established, and the features and value that they provide with this model, we're getting very, very close, and we're making some differences, of course, because again we're UTXO chain, and we're coming at this from a fresh set of eyes from the start. But I think if we can get this done and build these oracles, we'll be in a much better place for composability between different parts of the ecosystem.
I think it's kind of important to know that this is not Chainlink. It is not. It is important to emphasize that it is not. It is not a copy. It is not an imitation. It is not a thing, and it is very different. But it does hope to capture some of the nice things about it. So,
and I think capture it in a more simple way, right? There's not this middleman network that you have to involve and trust, right? Because you've got to trust that in that case, the Chainlink network is still working and is still valid and is still valuable and all of that. Whereas the thing that we're doing is all right on Bitcoin Cash layer one, right?
And
so you just have to know that Bitcoin Cash is still working. That's it.
And as with a lot of other things, there's a whole list of trade-offs that we will have to explore in the upcoming weeks and months. So,
yeah, and the incentive model between this and Chainlink is also different in a very significant aspect, in that Chainlink incentivizes production of data, while this model incentivizes consumption of data. And so the Oracle gets paid if people use it, not if the Oracle produced the data in the first place.
Yeah. Okay, fantastic. Thank you so much for correcting me, Jonathan. I really had a good time hearing it, because this is still new for us, right? We're still coming up with this. And Matthew posted on a reply to this thread where he said he thinks we should write a blog post or something about it. And he probably thinks we've thought about this way more than we have. But yeah, we're still going through it and coming up with the idea and sorting through issues. But this came from Jonathan. This design came from him. And like he said, this is a starting point. And maybe we'll write more about it when we have time, or if we're thinking about implementing it. But at the same time, it's already out there. So if somebody wants to do it and implement it, there it is. You can go for it.
Yeah. Also, I realized that while we're having the discussion, I'm sitting here and looking through the documentation that I've already written up. And yeah, I just posted a reply to our Twitter space with a link to a work in progress document. So if you want to go look at the documentation that already exists for this, you can do that there.
There it is.
Yeah.
All right. Yeah. So VM limits, we're looking forward to that.
Mountains of money, so we can hire people and make it happen.
Yes. Investors, please come talk to us. So we can make something better than Chainlink, faster, cheaper, more efficient, and more available. I'm not sure if people know, but using Chainlink is outrageously expensive for most cases. I think a lot have stopped using it because it's just not feasible. So this was great. The VM limits is something that we're very interested in. We're very much in favor of. I personally think it still needs a little bit more hard looks at the corners and edges to make sure that it's all been taken care of. The oracles are an interesting topic that it's one of those don't do evil, can't do evil things. So we've always taken those kinds of issues very seriously. And this design that Jonathan came up with, I think, is a great starting point. And I'm looking forward to see where that goes. So thank you, everybody, for joining us. I had asked in DM if some people wanted to ask questions, but I think people are digesting it, or will need to look at the spec and so forth to have comments and questions about it. So we'll bring it up another time. So thank you, everybody, for joining us, listening, and we will talk with you again next week. Take care, everybody.
Bye.